So we're starting to look at React today, and I guess it's going to take me 4 weeks or 4 lectures to get through what I want to get through. It's not going to get through all of it by any means, and behind this card, again, I'm being ambitious. I'm not sure if I'm going to get through these 2 set of slides or not, but we'll go as far as we can go and suffer the consequences. Right, so I'm going to start with this set of slides here. Now, I'm not getting a whole lot of interaction from me on the labs. That's okay. I mean, I'm providing the solutions, and I'm assuming you're kind of working your way through them. And that's fine. If you're working away on your own, I have no issues with that at all, but just don't fall into the trap of scanning over them thinking, yeah, I understand what's going on there, and then certainly hitting blocks further down the line, which I'm sure is not the case with you, but I just need to forewarn you, I guess. So going to look at what I'm calling the fundamentals of React today, and it's not really probably until next week that we will do any kind of proper React development. If you've been reading on React at all, then you may not notice the kind of code excerpts that you've seen on articles. You may not see them today, and that's okay, but you'll certainly see them from next week on. I'm going to give you a quick bigger background to the framework, to the technology. Obviously, we probably know that React is concerned with developing browser-based apps, and the browser is all about the user interface, and React is all about what we call the V part of MVC. You may have heard of MVC before. This is a design pattern linked with web apps, but it's actually also linked with desktop apps and any kind of application that has a user interface. And we will see that React doesn't really concern itself about the M or the C part. It only concerns itself with the V part. Then we'll talk about something called Jsx, which is this kind of sweet spot that the React framework gave the community. Jsx predates React, but the React team actually picked up, it's another third-party library. It picked up this technology and it made full use of it. And subsequently, other frameworks have used the same technology. So it's a lot about Jsx we'll see today. There are 2 tools that we will use in our development, and I want to introduce both of them today to you, and you will use both of them in the labs this week. Then we'll talk about the core construct that React builds upon, which is this notion of a component. We'll see the basics of components today and more about them next week. And if I've got time, then at the end, I'm going to talk about something called material design, which is a bit independent of everything else in this slide. But again, material design is something, it's another third-party library that we will be using throughout this module. So it's going to be very important, even though I won't necessarily be stepping through that in any kind of detail. You'll just kind of pick it up as you go along. That's the expectation. So React background, just first of all, a statement as to what this React.js thing is. It's a JavaScript library for building dynamic web-based user interfaces. By dynamic, I mean, if the user interacts with the interface, then what the user sees changes. It adapts based on the user's behavior. It's web-based, and it is all about the user interface, which is kind of this reference back to the V part of MVC that I mentioned at the outset. A technical classification for React is to say that it is a single page app framework. Now, where that name comes from, a single page app, I'll explain it later on, but there's no point in kind of getting into the rationale behind this term now, but that is strictly speaking what it is. And I'm saying it was open sourced roughly around 2012. You may know that React actually began a lot of software frameworks and tools, not just in the web space, but generally. A lot of them actually begin life as an in-house project in some software house, and that is the case with React. It probably wasn't called React back then. That's a label that Facebook put on it, but the framework itself began as an in-house project in the Instagram organization, and as we know, Facebook bought out Instagram, so Facebook got their hands on it. They liked it as it was just an in-house tool, as I say, or an in-house framework. They enhanced it, and fortunately for us, they actually open sourced it, which is why we can use it today. There are kind of nerdy discussions as to whether React is a framework or a library. We needn't get into that. There are slight technical differences between them, but as far as we're concerned, we would call it a framework. Now, React is a single page app framework, or it's a framework for developing dynamic web user interfaces, but it is by no means the first framework in that space. There are many that predate it. Angular is one, Angular version 1 now rather than Angular 2. Backbone is another. But the thing about React is that React made a lot of, or the React design team, those within Facebook anyway, made a lot of design decisions that were against the convention at the time. One of them is this MVC pattern idea. All of the other frameworks at the time forced the developer to structure their code according to this model view controller pattern. It's really a pattern that guides you in terms of how you should modularize your code. You have model parts, you have V parts, and you have C parts. Well, the React team decided we're not actually going to follow that. And in fact, we are only going to follow the V part of MVC. The M part is still very important, but they decided they weren't going to deal with that. M stands for model, which is really kind of the data side of your application. Of course, data is extremely important. And really, they left it up to the developer themselves or other third-party libraries to handle the M part. Now, more recently, React has kind of gotten involved in the M part as well, but for now, we'll just say that it is focused completely on the V part of MVC. So that was one design decision that the React design team made, which did not go according to what was the convention at the time. The second design decision that they made, which was against the grain, was to not use templating. You may have used templating somewhere along the lines in your in other modules or other development experience that you have. And we don't need to go into it, but again, they decided not to follow this templating approach. Templating is predominantly used as a technology for producing the V part or the user interface part of a web app. They said they were going to concentrate on this. They were going to use this component model approach. Now, every framework today practically follows this component model approach, but at the time, back in 2012-ish, the React framework was the only one that followed this component approach. And it was a fairly significant shift in the way it required the developer to kind of structure their code. The reasons they made these decisions, I'm kind of outlining in this table here. We needn't go into it in any great detail. Basically, they were kind of suggesting that by following this component model, you get a better separation of concerns in your code base. Number one. Number two, you use JavaScript and HTML to its fullest extent. The problem with templating was that you had to learn the templating syntax, which was an extra burden, and also the templating syntax was not nearly as powerful or expressive as something as mature as JavaScript and HTML. So for those reasons, they made these decisions. So we now know that React is all about building components as opposed to creating templates. And the reason really is, and secondly, we know that React is all about just the user interface part of a browser-based app, the V part of MVC. It doesn't concern itself with how you should structure the business logic in your app. or how you should structure the code associated with managing the data part of your app. Now, when I talk about, so now it means that a component, as React defines the term component, a component is comprised of two parts. And we know that a component is only concerned with the user interface. So a component has its UI description part, and it has its UI behavior part. We use HTML for describing the UI description part. In other words, how does the component display itself on the screen? How is it laid out? And HTML is all about that, really. In terms of UI behavior, by that we mean how does the component behave when the user interacts with it? Do we want some piece of logic to execute when the user interacts with it? And presumably the logic causes the component to change how it appears on the screen. How do we program that? Well, we program it using a language called JavaScript, which is a very powerful language. So as I said a few moments ago, JavaScript and HTML are the only two syntaxes that you need to be familiar with, and we are already familiar with them. And the developer community was already very familiar with both of these back in 2012. So that eased the learning curve. And the other thing about a component is, okay, we use these two languages to implement a component. The second thing that was very unique at the time was that we actually mixed HTML and JavaScript in the one physical file for a component. In other words, I'm saying here that they're very tightly coupled and they're actually co-located. Prior to this component model, we tended to put HTML in one file and JavaScript in a separate file, and somehow the framework would link them together. That wasn't the case and is not the case with React. So we're always, when we're implementing and updating and debugging a component, we're always inside in just one file, which just makes life a little bit easier for the developer. They're not flicking between files. And the benefits of this co-location of your UI description and UI behavior was, and also the benefit of using the single entity called a component for modeling your user interface, was that you achieved greater composition. You could actually compose components with other components, get them working together, and also you got greater usability of your components. And we'll see that later on as we get into the implementing of components. So if we just focus on the UI description part of a component first, how do we implement UI description according to React? And really, there is actually only one method that you need to use. Now, the React framework itself is broken up into a number of separate modules. There are two in particular. One is just called React itself, and there's another module called React DOM, DOM here from last week, document object model. The React module or library just provides one method that we need to use as developers called create element. And what that method does is it creates a HTML stroke DOM element. Now that's all it does. It just creates one for you. This React DOM.render, the React DOM library provides a single method called render, and it's this method that allows you to attach a new DOM element to the actual DOM itself. And we know from last week that when you modify the browser's DOM, then the browser will take care of ensuring it updates what the user sees on the screen. So really, when you boil it down to its very basics, there are only two methods that you ever need to use in order to implement any React app, no matter how simple or sophisticated it is. Now, the other thing that I want to say is that we never use the create element method directly. We do use the second one directly, but we never use the first one directly. If we did, then really the developer experience would be not very pleasant because we have to write a heck of a lot of invocations of that method. And it would be very imperative and kind of verbose in its look and feel. But we'll just stick with it now, and we will use them directly now so that you have a sense of what's going on behind the scenes. So to elaborate on those two a little bit more, so the React.createElement method, really, this is just a method associated, or a function, if you like, associated with this object, which is provided by the React framework. We give it 3 arguments. We tell it what type of element do we want to create. In other words, what type of HTML element, a H1, a div, whatever. We tell it what properties we want to associate with that element. Typically, that might mean what CSS classes do you want to attach to it, or do you want to associate some event handlers with it? And number 3, what child elements does it have? We know from last week that our HTML syntax is a nested. We can kind of nest elements within elements. Well, therefore, you know, as an obvious consequence, the create element method provided by React allows us to express that as well. So we'll see an example of this in a second. So there are the 3 parameters that you pass to this method. And what the method does is it creates a DOM element for the particular HTML element that you've asked it to. But of course, it doesn't actually attach that DOM element to the DOM structure itself. That's where React DOM.render comes in. And of course, as I've said already here, we never actually use this create element directly. We don't code it directly. We use it indirectly. And we'll see how that materializes in a while. The React DOM.render method, you've got to pass it 2 things. You've got to pass it a reference to the element that you want to attach to the DOM. In other words, the element created by the create element method. And where on the DOM do you want to attach it? So that's pretty straightforward. Now, to demonstrate this, I've got a few samples, and you can access the samples by clicking on the archive here on the right. Where's my mouse going to? If you just click on this, you'll download a zip and unzip it and import it into VS Code. So if I now do that, this is it here. Now, from here on in, really, anytime we will be working in JavaScript, we'll always see a file called package.json, and that contains some metadata about the particular project. In particular, and I think Frank will go into this a little bit more later on down the line with you, but for example, what you would include inside in package.json is references to the third-party libraries that we will be using for this particular project. And surprise, surprise, you know, we're actually referencing our 2 parts of the React framework, the React library, our package, and the React DOM package. You will hardly ever need to go into package.json. We will always provide the package.json for you, but just be aware of it there in the background. Now, once you have imported this into VS Code, and I have a little README that explains what you need to do, and it'll become second nature to you after a while. But the very first thing you've got to do is essentially install these 2 packages here. And the way you do that is by running the command npm install. I've already done it, hit return, and that's going to download the 2 packages from a remote repository. And it will put them into a subfolder called node modules, which you see here on the left. And again, you never need to go inside node modules, but it essentially has the packages that you've installed. It may have other packages installed as well, because React and React DOM, they use other packages, third-party packages or libraries. So having done that, what we will then do is we'll go back to our live server. And the first part I want to look at is, so these are all these are all, I don't want to go in there now really. I want to look at these ones here, right? I've just got some HTML files, good old HTML files. And if I open up this one and then start my live server, then it displays this on the screen. And this here was generated by React for me using the React.create element and the React DOM.render. So let's look at the actual code. It's pretty uninteresting stuff, but we've got to start somewhere. So here's a standard HTML file, and okay, I'm obviously bringing in my React, sorry, where are we? Here, okay, I'm bringing in my two React libraries, which is fairly standard. And then I've got my custom script that I've written here. So if we step our way through it, here we go, React.create element. So it looks like I'm creating a H1 element. Now, this is the properties that I want to associate with the element. Now, you know, from HTML, you can assign a CSS class to a HTML tag. We can't use the word class when we're using React because class is now a reserved word in the JavaScript language. And so instead of class, we just have class name. And really that's the only difference essentially between any HTML that we will write when we're developing our React components and normal static HTML, if you like. So class name here, I'm assigning it this string, and this is just really the name of a CSS class. You can see here, I've got a CSS file. Here it is here. And inside in that, I've just defined a simple CSS class for myself. I think that's what gives the background color to my header. So that's not too interesting. Sorry, open up that again. So the net effect of this is to create a DOM element, really create a HTML tag, a H1 tag with this CSS class. And technically, you know, the text of the tag is a child of the H1 element. So language is the child, but it's just the text of our header really. Next, we create an LI element, which is a list element, as you know. We don't associate any properties with it. And we want that to be the value associated with the list element. And similarly, we're actually creating 3 LI or list elements. Then we create a wrapper for those list elements, which is a UL element. I'm assuming now people are kind of familiar with these LI and UL elements from HTML. If not, just go back and do a quick revision of them. But my UL element, I don't any properties, but in terms of its children are the 3 LI elements that I've just created above it. And that makes sense because we wrap LI elements in a UL element, and we can have a variable number of children. That's the nice thing about the JavaScript language. You can have variable numbers of arguments to methods. Moving on, I then create a div, and inside in the div, I put my header element and my unordered lists. And finally, I do this. The final thing I do is I want to attach my div, which is really this, this React element. I want to attach that. Now, what is going on over here is old style DOM API code, which I briefly mentioned last week. This is the only old DOM API manipulation code that we will use. But the effect of what I've just highlighted there is telling React where to attach my new root element to. And what it's saying is attach it to the current element whose ID is this mount point. And if you look closely up at the top of the HTML file, I have a div here with that exact ID. So I'm attaching my new div with all its content to this point in the DOM. And once this line of code executes, that's what causes my browser to display this. So here's my header and here's my unordered list. If I simply comment out this line and save it, and of course, once I save it, then my live server updates what's in the browser. It updates or sends the update down to the browser. If I save that, go back to the browser, suddenly it's displaying nothing. So that's a key line. Until you attach something to the DOM using React DOM.render, then nothing appears on the screen. I'll just pause for a second in case there are any questions. Now, I would refer to this code here as vanilla React. And vanilla anything is something that we never write directly, but it is actually what's executed behind the scenes. But I'll just give you a second if you've got, or a moment if you've got anything that you want to ask me about what you're seeing here. No. If we move on to the second sample, which I'll bring up in the browser. The second sample, it's kind of awkward to get at it, but if we just go back to the root. Have I gone too far? I think I have. Just bear with me. Right, sample 2 is here. And it produces the exact same result. How I've written it is just slightly different. And before I show you what I've done is I'll explain what I did in sample 2. If you just take header here, for example, where I'm using header down here, if I just get rid of the variable itself, get rid of the variable and just put in what it's actually assigned to it. So if I grab this here, in other words, if I just nest my method calls, so if I stick that in there, just basic variable substitution, that's still going to work. In fact, if I just save it, I'm going to comment out all of this. Well, just take my word for it. You can play with it yourselves. But if I just do that, it's still going to work exactly the same for me. And so similarly, if I replace the list variable with what's actually assigned to it and keep on doing that variable substitution, then what I finish up with is what's in the O2 file. You can see here what I'm doing is I'm creating my root element, but I've got lots of React.create elements nested inside each other. That's just standard coding, really. And then, as before, I attach my root element to the DOM. So that's something that might become relevant later on. But other than that, it's just basic performing variable substitution in my 0-1 sample. That's all sample 2 is doing. Back to my slides. So, right. So we see now how to implement our UI description in React, but we are using what I'm calling an imperative programming approach to doing that, or what I also refer to as kind of vanilla React. I'm sure you're familiar with this term vanilla or imperative programming. It's just a generic programming paradigm. When you do any imperative programming, your programming involves writing a series of steps, and then the runtime will execute those series of steps kind of in a linear way. And that's exactly what was happening in the scripts, certainly the 0-1 script. The kind of opposite of imperative programming is something called declarative programming. And in the declarative programming, I'm saying it's a programming paradigm that expresses, it expresses the logic of some sort of computation without stating how it's actually executed, or without stating its control flow, if you like. Whereas in the imperative approach, we're describing the steps and the control flow for those series of steps. The series of steps in our case was, create element 1, create element 2, put element 2 inside element 1, and then finally attach it to the DOM. That's what we're doing right now. But as we'll see in a while, React programming is all about a declarative approach, and that turns out to be a much nicer developer experience. What am I showing you here? It's back to this Babel tool. Do we need to look at that now? Sorry, let me just check this. Oh, sorry, I skipped a slide. I knew that didn't make sense to me. Yeah, sorry. Right, back to UI descriptions, but now I want to look at how we describe the UI for in using React, but using a declarative programming style, which is a much more developer-friendly approach. And the key to this is this technology called Jsx, JavaScript Extension. And what Jsx is it's a declarative syntax for coding UI descriptions. And as I said, it predates React, but the React team leverages it fully. And what it allows us to do is, because JSX is really an extension to JavaScript, and we're going to use JSX to declaratively describe the UI for some piece of code, then it means that we can actually mix our JSX with ordinary JavaScript. So we can mix the UI description with the UI behavior. We haven't and won't look at UI behavior at all today, but that's where we will be going to. So JSX retains the full power of JavaScript, which is nice. So it's fully a very powerful language, and we will be able to leverage that in our declarative UI description code. And it allows us to tightly couple the UI behavior with the description, as I said. The problem with this JSX syntax, though, is that the browser does not know how to execute JSX. It has to be transpiled or converted back into plain old vanilla React, i.e. it has to be converted back to the type of React code that I've been looking at so far. That always has to happen. And when we send it down to the browser can only execute this vanilla React code. Fortunately, Babel just does that for us behind the scenes, and we've talked about Babel before, so I needn't go into that. If we now look at the next sample in our series of samples, and I've purposefully used error in the name for this file because it's not going to work directly when I send this HTML file down to the browser for the reason I just mentioned there. But let's look at it anyway. So here's the 03 sample. And again, it's a HTML file. And again, I am bringing in my node, my React and React DOM. And here's my custom script. But look what I'm doing here. I'm just creating a variable called root element. And I'm actually assigning a piece of what really looks like HTML syntax. I'm assigning it to a JavaScript variable. Technically now what I've highlighted is not straightforward HTML, it is really JSX. And the only difference between JSX and HTML is the fact that I'm using class name instead of class to refer to my CSS aspect of this UI description. But other than that, it is really plain HTML, and we're all very familiar with HTML. So I'm assigning this to a variable. The problem, though, is that when this code goes down to the browser, as I said, it cannot execute it because it doesn't understand this, especially like, for example, it doesn't understand this less than symbol as it appears here inside in some ordinary JavaScript. But if I try and run it anyway in the browser, so if I go back to my browser and look at sample 3, nothing appears. And if I open up my developer tools, it's telling me there's an error in my code. And if I expand it, what it's actually going to be complaining about is it doesn't recognize this symbol on a particular line. And that's the symbol that I just highlighted there a moment ago. So I can't send JSX down to the browser. So what I've got to do is I've got to transpile it. Now, for now, we're just going to do this kind of manually. And by manually, there are 2 options available to me. I can use the online Babel tool that I mentioned to you last week, which is this one here. And if I just go into try it out, just make sure that you have React selected here on the left, and that will allow me to use JSX. If I go back to my file, and if I just grab this bit of code here, I could grab the whole lot of it really, even though the last line would work. If I just grab that, copy, paste it in. And what we get on the right, do I have an error? It's probably why it's not coming out for me. Oh yeah, I'm just going to get rid of that line just for now, because it's not important. Okay, so what we have on the right is the vanilla React, or the vanilla, vanilla React code equivalent of what's on the left. And, you know, surprise, surprise, you know, create element is scattered all over it. So, but what we write is what's on the left, that's what we write. What's on the right is what is sent down to the browser, and Babel will do that for us automatically. So really, in order to get sample 3 working, I have got to do a little bit more work. And so what I've done here is I've inside in the JS folder, I've got, well, I've moved it on to sample 4, sorry. In sample 4, I have the raw, sorry, I've got the code that you write, which is this one. You write that, and then however I do it, whether I use the online tool or a command line tool, a Babel command line tool, I need to generate a separate second file, which is the transpiled version of it, which is this. And then in my HTML file, I simply reference this JavaScript code. And so that's what I've done in sample 4. Okay, and here is where do I reference it? I reference it here. So sample 4 is the exact same as sample 3, except I've gone through the transpilation process, and it's not terribly exciting, but sample 4 is obviously going to work for me. I go back to sample 4. Yeah. So we're getting slightly closer to where we want to be, really. We're now writing our React code in a declarative, using a declarative syntax. And we're just using Babel to transpile it into vanilla React for us. So that's where JSX comes into the equation. JSX is really, I'm saying it's a HTML-like markup syntax. Technically, it's actually XML, but to all intents and purposes, it is HTML. There are only very, very minor differences between HTML and JSX. We've seen one of them already, where you have to use the tag or the attribute class name instead of class if we want to associate some CSS styling with our particular DOM element or tag. I think that's the only one we'll actually come across. So we'll always be reading, when we're reading JSX, we'll really be reading HTML, and we're very familiar with that. And so now it actually, as I said, it allows us or it allows the UI description to be coded in a declarative style, and we can inline it with any other JavaScript that we want to have associated with the component, i.e. if we want to have some behavior associated with it. And so this JSX kind of gives us the best of both worlds. We've got, we can use HTML for the UI description, but we've also got the power of a mature language to write around that HTML. So we've got to transpile our JSX, and as we already know, what do we use to transpile it? We use this Babel platform. There is actually an alternative has emerged over the last year or two, but we will just stick with this Babel platform, this Babel tool set. Now, when do we, or how do we do the transpilation? There are a couple of options. One is we could do it manually, as I just did there. For example, I just copied and pasted the code into the online REPL tool and did it that way. There's a command line tool that you could use. Neither of them are really scale as such. The second approach is what we will see during the remainder of this part of the module. You can get web servers that have special kind of instrumentation or tooling built into them. And what those web servers will do is they will monitor the various files in your project. And if you make a change to any file that contains JSX, it will just retranspile it immediately and send it down to the browser immediately. So it does this automatically in the background. These web servers, you know, what they're actually using is a tool called Webpack, and Webpack uses Babel. And we never need to worry about Webpack. It's just taken care of for us. Although if we were an experienced developers in React, we would be interested in tweaking Webpack, all right, but not in our case. So option 2 there is what we do a lot when we're developing our React application. But clearly, you know, this idea of having a server running in the background and monitoring any file changes and doing retranspilation on the fly, clearly that's not appropriate for a production version or a deployed version of your React app. In other words, a version of your React app that your users are accessing. You can't have this transpilation going on in the background. So instead, what we use when we eventually want to deploy our React app to some sort of cloud service is we use a build tool or a bundler tool, and it takes care of essentially taking all our code, transpiling the whole lot of it, and bundling it or packaging it into one large JS file. And again, we'll see that in action in this module. So 2 and 3 are really the options available to us. We never use 1. Now, we haven't seen a component yet. We have seen JSX, all right, but we haven't seen a component. So what is a component? Quite simply, a component is a JavaScript function that returns JSX. It may have other logic in it because it's just a function, but its return statement has to return a snippet of JSX. And that return value is essentially what that component wants to have rendered on the browser screen. And we can kind of reference a component just like any HTML element. So this kind of statement here is actually going to work. And when we read this here, it looks like component X is some new HTML tag that we've just come up with. So in a sense, React is about developing your own custom HTML tags. You could view it like that. So sample 5 eventually is our first look at a React component. So if we look at this particular file, now there's nothing interesting inside the HTML file because all it's doing is it's referencing a local JavaScript file. And if I go up into my JavaScript folder, you can see I have 205 files. And again, one of them contains the source code, the declarative code that I as a developer writes. The other one contains the transpiled code that's actually sent down to the browser. And it's that second one that is being referred to from my HTML. So, but as developers, really, and I've called them source and transpiled. As developers, this is the one that we're interested in. So here's our first look at a React component. It's a function, as I said on the previous, on the slide. So here I'm just declaring a variable, but I'm assigning it an arrow function. So this arrow function is my component implementation. There's no logic in this function, but later on we'll be putting logic in here. It has a return statement and it is returning JSX. Again, if I cut and paste that and go over to my online transpiler, then what it would produce is this guy. And really from here on in now, we never really are going to look at the transpiled code, but not surprisingly, it's got React.create elements still going on behind the scenes. So we're never only more than one step away from that. But as developers, we write our declarative syntax, which is this. So that's our first example of a React component. And clearly, you know, if we want to run display sample 5, then we get the same, nearly the same output again. Did somebody want to ask something? No? Okay, moving on. Okay, so let's park components there for a while, and let's just briefly talk about the tools that we're going to use during this part of the module. There are essentially two that we're going to use. One is called Create React App, and as its name kind of suggests, it is a tool for creating React apps, and it has a couple of features to it. It will generate a kind of template project for you. It will do some scaffolding. In other words, it will create some boilerplate code if it's needed, and it'll create a folder structure for you, and then you can enhance that. Secondly, it comes with its own development server, its own development web server, which I was talking about there a moment ago. That will do transpilation for us on the fly as we're doing our development. And thirdly, it comes with its own bundler or build tool to create a production standard version of our app so that we can deploy it. Now, other than that, we don't need to, we will be using Create React App throughout this module, but other than that, we don't need to know anything else about the internals of it. So it is a tool for creating your startup React app, if you like. The second tool is called Storybook. It's kind of an unusual name. I'll explain in a minute where it comes from. But what Storybook is a tool for developing individual components. And really, as developers, that's kind of what you do. You might develop individual components and then compose them together into an app. So the Storybook tool is really nice for just focusing in on a single component. I'm saying it's a development environment for creating React components, and it allows you to focus in on a component rather than being worried about the app environment that a component might be running in. Notionally, it causes you to develop better components when you're kind of focusing in on them in isolation. Promotes good practices really in terms of designing your components, in terms of reusability and testability, etc. And again, also it's probably quicker to produce components rather than trying to artificially stitch a component into a shell kind of app, which may always is kind of tricky really. So if we talk a little bit about the Storybook one, because that's the one that we'll be using in the first of this week's lab, and the Create React App is the one we'll be using the second lab. So Storybook is just installed as another third-party library, which we will do. Really what you do is you reference it inside in your package.json file. And it has three parts to it. It has an API or a library, and this API or library is what we use to write our component stories. I'll explain in a minute what I mean by a component story. So the API that comes with Storybook is not for creating components. It's actually for writing stories, which are really kind of our test cases for our components. Secondly, it also has its own web server, which does transpilation behind the scenes for us. It's a development server. And number three, it has a nice browser-based user interface, which makes it easier for us to kind of catalog and look at our separate components in isolation. Because we always want to know, well, what does my component look like? How does it render or display on the screen? When we're developing a component, that's the first thing we want to know. How does it display on the screen? And so the user interface that comes with the Storybook tool makes it easier for us to achieve that. This is what the Storybook user interface looks like. So what it's showing you here is on the left, it will show you a list of all of the components that you have developed so far within the particular project that you're working on. So it somehow will be able to pick up the various component implementations that you have, and it'll list those on the left. And these are clickable. And if you click on them, it will display that component on the right. So we can see whether it's displaying properly or not, and tweak it if the styling is out or if there are some other issues with it. So we can look at these individual components in isolation, which is the whole point. What do we mean by a story in the context of this whole React component? And the term really comes from user stories in the area of user requirements analysis, which is all back to systems analysis and design, if you ever studied that anywhere along the lines in your undergraduate studies. And if you're familiar with user stories, that's where it comes from. But to relate it to components, if you think about it, it turns out, right, that components, obviously they will have data associated with them, because typically what a component is a way of displaying data on the screen. And typically, more than likely, that data came from some sort of backend server. And that data or state may have different values, and the values associated with that state may actually change the way you want your component to render. This is a design decision, again, that you would have to make. To give you a tangible example, if you think of the component that we have just developed there a few moments ago, this component that displays a list of programming languages. Supposing I decided, and I'm saying it down here, supposing I decided that I want that component to render slightly differently depending on how many languages were in the list. So the list of languages is my data or my state associated with this component. And I've kind of arbitrarily decided, look, if there are 5 or less languages in the list, then I want it to display just that list of languages, which is really what we've had so far. However, if there are no languages in the list, that might be an exceptional case, but it might exist. If there are no languages, then I don't want the component to render nothing. I just want it to render this message. And thirdly, if there are more than 5, then I want the component to list the first 5 on the screen and have some sort of more button or link that the user can click on. And if they click on it, then it displays the next 5, and they can page through the different languages in my list. So I would say that these are 3 stories that I have come up with for this particular component. And I've just given the stories labels that are hopefully kind of meaningful, right? Now, I need to somehow express all of this to Storybook. And we'll see how we do that in a second. But that's where the term story comes from in Storybook. We define the stories associated with our components. Now, to be honest, in the vast majority of cases, all of your components will only have one story, but I'll give you the full picture anyway. When you have multiple stories associated with a component and you've expressed this using the Storybook API, which we've yet to look at, what Storybook will then do for you is it will list those different stories or states underneath the component. And now these are clickable. And so when you click on one of them, you'll see how the component renders for that particular story. So it looks like I've clicked on the one where I've got more than 5 languages in my list, and it's listing the first 5, and I've got my kind of more linked here. Furthermore, when you've got a large project, you may have quite a large number of components, and rather than listing them in a very long linear list here, what you can do with Storybook is group them into some sort of meaningful categories in the context of the application itself. And you can express these groupings to Storybook. And so now Storybook will somehow put them together into the groupings that you've asked it to. And that just makes it easier for other people on the team to look down through your component catalog and get a sense of the different components that make up your application. I need to go off on a tangent now for a second. What I really want to look at next is, well, how do I implement stories using the Storybook API? Before I can talk about that, I just need to go back to something linked to the JavaScript language itself, something we haven't covered. Obviously, when you're writing JavaScript, any JavaScript application, you're going to break your source code up into multiple files, which we call modules. And modules will need to access other modules. In other words, you need to be able to import within one module, you want to be able to import other modules because you want to use some functions or classes defined within it. So how do we express this in JavaScript? And there is a way that we used to do it pre-ES6 and post-ES6. In pre-ES6, we had to actually use a separate library. It wasn't native to the language. We had to use a separate library called the CommonJS library to achieve this. We won't need to look at that because we are going to be writing all of our JavaScript code in ES6 and beyond. And the nice thing is that in ES6 version of JavaScript, modularity is actually built into the language itself. And this ES6 modularity provides a number of different ways of expressing the modularity of our code base. We can have what are called default exports within our code or named exports within our code. And you can actually have a mixture of them, and we will see the mixture a lot. To show you the syntax, so on the left here, let's suppose I've got 2 JavaScript files. One is called lib.js, and inside it, I've got some code for a function, but I want to make this function available to other modules. So I need to prefix it with this export statement. And I'm saying that this is the default export from this file. In other words, it is the only exported part of the contents of this file. In a separate file, which I've just arbitrarily called bar.js, it looks like here is where I express that I want to import or utilize the function defined in the other file. Note I haven't given the function a name here, and that's not necessary when it is only exporting one thing. The name that I want to give it is here, and it can be anything you want it to be. So this is how I'm importing my function from the other module, and I have to give the path name of the other file, a relative path name, and then I just invoke the function as normal. So that's fairly standard stuff. If you've done any kind of modularity in any other language, certainly in Java, this looks very like it. This is what we would call the default export facility available to us from ES6. On the right, I've got something a little bit more elaborate. Again, I've got this lib.js file, which is exporting a number of different things. It's exporting a string, and it's exporting a constant, and it's exporting a function, and it's exporting a class. So it's got multiple exports. And when you've got multiple exports, you've got to give them individual names. So we would refer to these here now as named exports. Now, in my other file, I don't want all of the exported features in lib.js. I only want some of them. And so what we need to do is we need to wrap the ones that we're interested in curly braces. And in this case now, we do need to know the exact names of the entities that we are importing. So these names here have to correspond to whatever you call them up here. And then we use them as before. So these are named exports, whereas on the left we have default exports, and you can have a mixture of both. So inside this file here, I could have had a default export as well. And how I import the default and the named ones looks slightly different, and we will see that later on down the line. Back to Storybook, and how do we write stories for our components? So we've developed a component and we want to check, well, does this component render properly? So what I need to do is write a story for it and then use Storybook to actually render that component for me. So what we do is we create a file called with the .stories.js extension. That's kind of arbitrary, really. You could give it any extension you want to. Obviously, it has to have .js, but the .stories part is arbitrary. It's convention, though. We create one of these files for each of our components, and this is what the layout of the file is going to look like. So if I take it from the top down, obviously I need to import React. By the way, when you're importing a third-party library, you just specify the library name, whereas when you're importing a local module, you have to specify the path name of where that module is. So in this case here, in this example, this is where I have the implementation of the component that I want Storybook to render for me. And this is where I'm just importing the React library itself. The first part of the story implementation is what I'm calling metadata. So, and it has to be the default export. This is where, this is why I covered modularity on the previous slide. So the default export from your stories file contains metadata. Really, it's just an object that you're exporting, and the object has to have predefined properties. So the title property is really what this is what will appear on the left of our Storybook UI, but it's some sort of close English kind of representation of the component itself. And component has to refer to an instance. Sorry, component has to refer to the name that you gave the component here that you've imported. That's number one. Then here is where we actually write our stories. So I would say this is a story implementation for my dynamic languages component, and it's a very simple one. It has to be a named export. It doesn't matter what you call it, but it has to be named. And inside the and it's implemented as a function. So we know that now that we implement stories as functions. I'm using the arrow syntax, but you can use any syntax you want to. Declarative or declarative, I suppose, is the function expression. Sorry, is probably the only other option available to you. And you can have any logic you want to in the body of this function, but critically, it has to return an instance of the component. And it looks like what I'm doing here is I'm setting up my array of languages. Now, what I'm doing here is I'm passing the languages into the component. We haven't seen this so far. The component, the only component that we looked at, it didn't receive any properties or arguments passed into it. This is how you actually do it, but we'll cover that formally in a minute. So this is my story implementation. It has to be implemented as a named export function, and it has to return an instance of the component with, the relevant attributes for that component corresponding to the story that implementation, that story kind of corresponds to. And I haven't shown you the detail, but we have, if you remember, we had 3 stories for our dynamic languages component. So here are the 2 other stories, which I've just taken out the detail because it's not important. All I'm really interested in is the flow of the code that you have here, or the structure of the code that you need to write to satisfy the Storybook API. So having written all of that, that's what allows Storybook to, if I go back, that's what allows Storybook to, generate this stuff here on the left. And by clicking on, then it'll show you the component actually rendering. And you will do that in this week's first lab. It's all about using the Storybook with our component. Now, if you happen to read around Storybook at all, read articles, and if you start seeing implementations of stories that look like this, which is very different from what I've just shown you, then you are reading an article that is too old, really. The Storybook API changed about maybe 2 years ago. It changed from this style here, which was using a lot of kind of meta chaining and difficult to read. It changed from that to this format here, which is cleaner once you get familiar with it. So that's Storybook and writing stories for our components so that we can see that the component is rendering properly. It's not great now for checking that your component's behavior is working properly, because behavior tends to be more associated with, well, when the component is interacting with other components. And when you're at that level, you're really then talking about the behavior of your app rather than individual components. So Storybook is really about making sure that your components at least render properly, display on the screen properly for different scenarios, i.e. different stories. Oh yeah, I mentioned there that you can group your components into groupings. And so how would we tell Storybook that two components belong to the same group? Well, the way you do it is in the metadata structure at the top of your stories file. And this slash here is kind of significant. It's the kind of path name kind of syntax that we're using. What this is actually telling Storybook is, I want you to display the stories associated with this component. I want you to display them under the group called Group A. Whereas here I'm telling it for this particular stories and its associated component, well, for this one, I also want it to be under the Group A category, whereas this one is going to be under the Group B category. So that slash there is significant, and that tells the Storybook server and the Storybook UI how it should group the components that it displays on the left-hand side of its user interface. Now, so the reason I'm covering Storybook is because we're going to use Storybook to look at some other aspects of component syntax, because there's no point in me saying, look, here's some component syntax and this is what it does. We really want to see it producing the output on the screen, and the way we're going to do that is to use Storybook to facilitate that. So if we now switch our brains back to components and just forget about Storybook for a moment. And the way I'm going to walk my way through this is I've given you another archive. This archive now you will get in the first of this week's lab. And when you download it and unzip it and import it into VS Code, what you will see is what's on the right here. And so if I just kind of step my way through it, I've got a source folder, and it seems to have a subfolder called components. So presumably inside here is where I'm going to have my actual component implementations. And I've broken the components folder into two subfolders, one called exercises and one called samples. In the samples, I'm giving you the actual code for the components. The exercises is where you will put your component implementations as you work your way through the lab. So there are components, and then further down, I have a subfolder called stories, and surprise, surprise, that's where we're going to have our story implementations. And I've followed the same subfolder structure as the component folder. So I've got an exercises and samples within stories as well. I'm giving you the story implementations both for the samples and the exercises. So you won't have to write the storybook code for the exercises, but you should certainly look at it so that you're comfortable reading that code. And when you run npm install to install React and Storybook, because Storybook is just a third-party library that you need to install. And if you start up the Storybook server, and we'll see how to do that, then what it's going to display is what's on the left here. So here's the left-hand side of my Storybook browser-based user interface. And I've actually, just for convenience, I've defined two groupings for my components, one called the exercise grouping and the other is called the samples grouping, which kind of made sense in the context of what we're trying to achieve here. I've also given names to the components which will help us to relate this here to the particular files over here. Normally what you would have here is some sort of is the name associated with the component rather than this kind of long expressive thing here. But yeah, my rationale for using this kind of labeling was so that you could link one of these to the relevant sample or exercise file and the relevant story. So let me just do that, I suppose, if I go into VS Code and get out of all of this stuff. So I appreciate now there's a lot of moving parts all of a sudden to all of this. What's going on? Totally mess. Don't save. And here is, so you get at this now from the lab, the first of this week's two labs. And I've already ran, you can see there's a package.json down at the bottom, and I've already ran npm install. And if I just quickly look inside package.json, I am asking it to install, let's see, React and React DOM as before, but then I've got various kind of Storybook related stuff. And you needn't worry about this. You can just take it as read. We don't have to rationale why we implemented all of these individual Storybook stuff. And there's some Babel stuff that's coming in there as well. But don't worry about that. The reason there are two, the reason we put our third-party libraries into two different categories is one here called dev dependencies and another one called dependencies. Dependencies are runtime related third-party libraries, whereas the dev dependencies are third-party libraries that are only required when you're doing development. And I want to start my Storybook server. And the way I'm going to do that is just run npm start. Sorry, not npm start, npm run Storybook. Npm Run Storybook is really, it's a shorthand for, where have I got it? Oh, yeah, there we go. Just shorthand for this kind of longer command here. So I could have submitted this from the command line, but this is slightly shorter. And when I hit return here now, what's going to happen is the Storybook server is going to start up. And it is actually going to go right through all of my source folder. It's going to pick up all of the components. It's going to pick up all of the stories. It's going to transpile all of that code. and it's going to send the whole lot down to the browser, plus the Storybook UI code, and the browser then will render accordingly on the screen. So if I just hit return, you'll see that there's going to be a lot of work going on behind the scenes. So it's effectively going through all of the code now, transpiling everything, sending it down to the browser, and voila. And on the left now, if I click through the samples, because they're actually implemented, here are my components that I have implemented. So I want to kind of work my way through these samples one by one, and each sample is just demonstrating a feature of React for me. Before I move off this, is there anything else I want to mention? I don't think so. Yeah, I'm just mentioning here, like there is a .storybook folder in my project as well. You will never need to go near that, but what it contains is configuration information for Storybook. Essentially, if you did look inside, there are two files inside here, but in one of the files in there essentially tells Storybook where to find the story implementations. And it will point it down here. And so Storybook will then go through the various story implementations. And inside the story implementations, you have imports to the actual components. So that allows it to find the components. And as I've already said, it kind of transpiles everything and sends it all down to the browser. So the first thing I want to talk about in relation to React and components and JSX is how do I embed variables in my JSX syntax? Because so far the JSX that we've seen is completely static. So if we look at the sample here, I've got a simple component and it's declaring two variables, and I want to embed the references to these two variables in my JSX. And you can see me doing it here, for example. I'm referring to one of my entries in my array that I've declared. Now, what you need to do is you need to wrap the reference in curly braces within your JSX syntax. And so once React sees these curly braces, it knows it needs to evaluate this first before it works out, well, what should be the text associated with this li element. There's something slightly more elaborate going on here. Here I'm actually using the JavaScript string templating syntax, which we briefly mentioned, is it 2 weeks ago now? I'm actually encoding a JavaScript string template, and we know how they work. So again, what's going to happen behind the scenes is this string template is going to be evaluated fully. And then the output of that is going to be what is my H1 element. But again, I've got to wrap this in, I've got to wrap it in these curly braces here, opening and closing. Now it turns out, sorry, my, my opening curly brace and my closing curly brace over here. Now it happens to be that the string templating also uses these curly braces, but we know about that. That's just coincidental. So how do I embed variables in my JSX? Well, just make sure that you wrap the variable or indeed the expression in these curly braces, and the React runtime will evaluate them before inserting the result into the actual HTML/JSX. And you can have anything you want to inside these curly braces. For example, if you want to call a function and the result of that function is what you want to have associated with the H1 element, then that's going to work fine. You just simply invoke the function within your curly braces. So this is sample 02 in my list of samples. So if I look at the detail of that, I can look at the component first, which is here. And it's really what we've just been looking at. In terms of the story, and we use the numbering system now to help us to find the corresponding stories. I think there's only one. So if I go down to my stories file folder and dig into the samples and further down into the 02 sample, here's my story implementation. Not too interesting, really. There is only one story. This is strictly speaking the story implementation, and I'm just returning the component as I'm required to do within the story implementation. And here's my metadata. And so, you know, if I change this to whatever, let's say embedded variable demo, and save that, then you can see, you know, it has modified it here. And by clicking on it, I get, is that 02? Sorry, wrong one, this one up here. Clicking on it, I get that. And does that match up? If I look at what's being rendered, modern languages, Go, Julia, and Kotlin, does that correspond to what I put into the actual component? Yeah, that looks about right. And if I change any of these, you know, if I go Golang, save it, and it updates it accordingly. So that's kind of nice. Now, you know, changing the actual data isn't typically what you would do when you're doing development of a component. You might actually change the styling or something like that, and you want to see immediately how does it render. That's where Storybook becomes really useful. But for now, in terms of React and components in JSX, this is how we embed expressions really within our JSX code, just wrapped in curly braces. The next thing I want to talk about is reusability. How do we make our components reusable? Up to now, our component is completely insulated. We cannot, for example, we can't pass data into it. It would be nice if we could pass our array of languages and our header into the component, and then it is much more reusable. So in other words, we want to parameterize our component. And in the world of React, we refer to the parameters as props or properties. And so a component's properties or attributes or parameters is what we want to achieve here. And there are two things that we need to know about. A, how do we pass props into a component? How do we pass parameters into it? And I'm showing you how to do it here. And it's really takes its syntax from the HTML world. These look like attributes associated with a tag in HTML world. So it looks like for this particular generic component, I want a prop, and you can call the prop, give them any name you want to. And how I assign a value to the prop is like this, but I've got to use my JSX curly braces to ensure that what's inside here is evaluated first before the value is actually sent down into component. And I've got a second prop. That's number one. How do I tell React that a component is going to have certain attributes associated with it? Number two, within the component, how do I access these attributes? And it turns out that by default, your component function automatically has an argument. You can call it anything you want to, but the convention is to call it props. And the runtime will take care of instantiating this. It's an object, really. It's a JavaScript object. It'll instantiate this object for you, and the key value pairs within this object will correspond to what you've set up here. And so you can see inside in the body of my component, I am simply dereferencing using the dot syntax props dot prop name one. So that expression is going to evaluate to whatever value you assigned up here. So now P1 is going to refer to the value, and I can do whatever I want to with that within my component, presumably add it to the JSX or maybe do some computation on it. So that's how I parameterize or make my component reusable, I do it through the medium of props. What is very important to remember about props is they are immutable. You cannot change them inside in the component. Syntactically, it will allow you to do it, but it won't actually affect the change at all. It's very important to remember that, and that was a conscious design decision made by the React team. And there's good reasons for it. Secondly, I'm saying, well, deciding what are the props for a component and what names to give them, that's really a kind of design decision associated with the component and what you're using it for and what the props actually represent in terms of their kind of real world corresponding. Okay, that's reusability and this notion of props. And we have an illustration of that. Moving on to sample 3. So not surprisingly, in sample 3, I think I'm passing in my array of languages and my header into the component. And so if I look at the component first, you can see in the body, in the return of the component is where I'm actually dereferencing the prop. And again, I've wrapped it in curly braces and similarly here. Now our story now is going to get slightly more interesting because our story now needs to give values to these actual props. And so if I look at the corresponding story, again, there's only one, but here I'm instantiating my array, instantiating my header, and here we go passing in props, which I've decided to call languages and header. And those names, languages and header, they obviously, they have to match up with the name that you used in the actual component. Sorry, if I go back to my component. Sorry, sample 3. Beg your pardon. They have to match up properly. Clearly, if I do something like misspell it, then that's going to cause problems. Voila, our friend undefined, because that expression prop start headings without the S evaluates to undefined. And so that might be, you know, a typical kind of admittedly beginner's mistake that you would make, and Storybook is informing you of it before you start putting the component into an app. That's this notion of reusability, or props, really. Next, we go off on a tangent again. I do this quite a lot, but there's reasoning behind it. I'm just reminding you about the syntax associated with JavaScript arrow functions and the fact that a lot of the syntax is optional. And so, for example, these two arrow functions are identical. Here, I'm using the full syntax, whereas here I've dropped a lot of the syntax. You know, I've no return statement, I've no curly braces, etc., etc. Don't need to explain that to you. I'm just reminding you of that. That's number one. Number two, we are very familiar with the map function associated with arrays and what map does for it. I'm just reminding you again, but I'm not going to explain this because we've had it a lot in week 2. Third thing, I'm just informing you or kind of reminding you of it, even though it was only earlier on in this lecture that we covered it. And this does kind of look odd, but when I explain why this is possible, it makes perfect sense. Like, it's okay to assign some JSX, a single JSX snippet, assigning that to a variable. That works perfectly for us as an assignment statement. And the reason is, when this gets transpiled, turns out to be this. And this is just normal kind of call a method on an object, and whatever that method returns, assign that to the variable. And that's really all that's going on up here when it's transpiled. So taking those 3 bits of information on board, the next thing we want to look at in relation to JSX and components is, what if I want to generate, I'm saying, an array of similar JSX elements or even similar JSX components from a data array. So I've got this array with data in it, and for each entry in the array, I want to generate a JSX element. And so I will finish up with an array of JSX elements, and then I want to display that array. This is something that we see happening a lot as we work our way through this. And there's a pattern for it that we will just use all over the place. So we're doing this as sample 4. And maybe if I look at sample 4 first, see how it renders. So, okay, in this case, it's an array of single page app framework names, and they're hyperlinked. So these elements here, these are LI elements, but they also are using the HTML anchor tag. And so the actual HTML associated with this list is going to look like this. So I've got a sequence of LI elements with nested elements within them, but I want to generate this entire set of LI elements. I want to generate it in some sort of efficient way, and that efficiency will come through using the map function and arrow functions, as we'll see in a second. So if we look, I suppose, at the detail of sample 4, and I'm going to pass my array of languages into the component as a prop again. Or sorry, it's not an array of languages in this case. It's going to be an array of, let's look at the stories first, actually, in this case. Sometimes you're better off looking at the stories first rather than component. So if we move on to sample 5.4, wasn't it? Yeah, here we go. So I've created this array of objects, and each object contains a single page app framework name, its URL, and I've got just a standard kind of header, and I'm passing all of that into my component. So the interesting one is this one here, passing in this array of objects that you see there. So what does the component do with that array? And this is the pattern that I was mentioning, what's going on here. So here's my array. And I'm calling map on that array, and I'm passing map my callback, which as we know. So f here, the variable f, is going to refer to one of those objects in the array, and index, we know what that does. And I'm using the f reference to generate this piece of JSX. And because this is the only statement within my callback, this is effectively what is returned. So in other words, this array here is going to contain elements made up of this LI with a nested anchor tag within it. Okay, I'll say that again. This is going to be an array, and each element in that array is going to be one of these. And then I just simply actually reference that list and embed it with an UL element, which makes sense because this list is going to be an array of LI elements, and wrapping that in a UL element is logically right from a HTML perspective. But the interesting thing here really is obviously this idea of mapping over a data array to generate an array of JSX elements. Equally, if we had a component, we could put a component in here instead if we want to generate an array of components for ourselves. And we will see that happening later on. I would obviously encourage you to go back and look at that and make sure you understand that sample, because that pattern keeps reappearing throughout the module. I'll just pause for a second. I know I'm going through this stuff at a fair pace, but in case there are any questions that arise. No, okay. Now, a component returns a value. Well, a component is a function, and a function can only return one value. That's no different when the function implements a component. And we know that the value that a component function returns has to be JSX. So, maybe a component simply returns a reference to some other component, or a component can return a snippet of JSX. By the way, if the JSX is like this, if it's a multi-line, which in pretty much every case it will be, if it's a multi-line piece of JSX, then you have to wrap it in parentheses. And that really helps the Babel transpiler to kind of work its way through, because it needs to transpile all of this back to React.createElement invocation. So it really needs to know where does it begin and end. So that's fine. The next thing I'm just saying here, and it's probably one of the errors that you will come across at some stage, is that the JSX that a component returns has to be comprised of just one element. So in the example that I'm showing you here, this isn't going to work, because in this case, it's returning a H1, and then it's returning this, and then a paragraph. So it's trying to return three different things. And that's going to cause the React, where does it arise actually? I think the runtime, it's when you get to runtime, in other words, within the browser, it's going to throw an error because it cannot work out this. It can only return one thing. Here we're trying to return three things. Now it's and this is the error that you will get in the browser. It's very easy to fix this. All you've got to do is just simply wrap it in a div. So we found ourselves doing that quite a lot, artificially wrapping our JSX in divs just to satisfy this constraint. So that's what you do. Or should I say, that's what you used to do up until some version of React that allowed us to change it. I can't remember the version, but so the old way was to wrap it in a div. Now, the problem though with that solution was it meant that our DOM, that structure within the browser, it became a very deeply nested structure, because we had all these extra divs just to satisfy this constraint that I'm talking about. And really, the larger the DOM data structure is, that is going to affect the browser's repainting kind of process. Remember this idea that if you change the DOM, then the browser reanalyzes the DOM and updates and repaints it on the screen. Well, if you've got all of these nested divs within divs, then it just takes the browser longer to navigate down to the DOM to work out what has changed. So that was a problem in the early days with React for very large React applications, obviously. So the React team came up with a solution, and the solution is what you see on the right. They gave us a special tag called the fragment tag, and it does the exact same thing as the div does on the left. The benefit though of this fragment tag is that it has no corresponding representation on the DOM. And so that solved the problem that I've just been describing. And we'll see ourselves using this fragment tag a lot. Now, if you actually want to associate some CSS with this whole section here, then you do have to revert back to using the div tag, because you cannot assign any CSS styling to this fragment tag. Now, here's a big statement, but it's true. I'm saying all React applications are designed as a hierarchy of components. You will never get away from that. Every single React app is a hierarchy of components. In other words, there's a component at the very top of the hierarchy. It has children. Those child components have their children, and on the hierarchy goes. It doesn't have to be a balanced hierarchy, but it does have to form a kind of perfect hierarchy with one component at the top. And typically the component at the top, and indeed the components at the top part of your hierarchy, typically they don't render anything explicitly. It's really the components at the bottom part of the hierarchy that contain the actual detail of what's displayed on the screen. The components at the top still return JSX, but the JSX is really only going to contain references to other components rather than references to actual HTML tags. Now, we want to demonstrate this, and so oh yeah, we refer to the sub components as children, obviously, which we would do in the HTML world as well. So in other words, really your hierarchy of components that follows the HTML kind of style of HTML tags having nested HTML tags within them, which we often refer to as children. And we've got an example of this in sample 5. This is what sample 5 renders like on the right. So this sample has 3 components, and it has one component at the top, and that component has 2 subordinates. So one of the subordinate components renders this, and the other subordinate component renders this. And the component at the top, it renders some specific HTML as well, but it also kind of controls the other 2 components, if you like. So maybe if we look at the source code, I suppose, for sample 5. Now I'm reusing some of the other components that I have from earlier on. So I'm reusing this component here, the one that displays a list of languages, and I'm reusing the component that displays my list of frameworks. And here's Maria, my component at the top. And it looks like it's going to be passed in the array of languages and the array of frameworks. And then within its return statement, you know, it has some custom HTML, as in sort of this stuff here. And it also is reusing, I suppose, or leveraging other components within the project. So here's one component that it's using, and here's the other component that it's using. So we've got a mixture of component references and raw HTML. We're combining or composing these together within this higher level component, if you like. Hence, we've got a hierarchy. This is at the top of the hierarchy, and this one are children components to the top one. Other than that, you know, the story is only going to refer to the component at the top of the hierarchy. So which number are we on to? 0, 5. Okay, I've got all of that. I could have maybe pulled this in from the other file, but I didn't bother because it doesn't export them. And where is my story? Sorry, no, just give me a second. Oh yeah, this is really the story here. And here's the return statement. So what it's returning is the component at the top of the hierarchy passing in the props into it. And in fact, it's just only passing in one prop, but that one prop contains all of the data, as you can see. Right. Now, just before I move off, we should only really use Storybook for rendering a single component. I'm using Storybook here to render a hierarchy of components. And we don't tend to use Storybook for that, but I had to have some way of showing you, well, how does this 0.5 component actually display on the screen? That's why I'm using Storybook to do it for me. But you wouldn't tend to do that. I'm just by the way, kind of letting you know about that. Okay, what's next? All right, so you know we've covered a lot of ground there now. We've introduced this Jsx syntax. We have talked about the key construct that React uses, which is this component construct. Our components so far are static. There is no dynamics or behavior built into them. That comes next week. But for now, there's a lot that we have covered, and we've looked predominantly at the Storybook tool, which helps us to develop individual components. And so all of that now is covered in this lab here. This lab uses the other tool, Create React App, and I'm not going to talk my way through Create React App in a lecture. You should be able to make sense of what Create React App is doing for you once you've worked your way through this lab. And really, all that you learn about Create React App in this lab is all you will need to know about the tool. And indeed, all you will learn about Storybook in this lab. It doesn't get any, we don't go any further in the Storybook tool. That's enough to satisfy the requirements that we have for the rest of this section of the module. Now, this is heavy going, I know, but I might just start this set of slides if I can. Or should I? Because maybe what I might do actually, because I might actually record, because it would only take me about 10 or 15 minutes to walk through the other set of slides. I might record that separately and tag it on to the end of this recording, or put it up as a separate recording on the website, rather than kind of try and work our way through it now. So maybe I'll just pause the lecture there. If you've got any questions, don't know if you have or not. Just going to turn my camera back on. No. Okay, so work your way through the labs. Now, in the first lab, I do provide solutions, but try and resist the temptation to just start looking at the solutions to try and work them yourselves first. In the second lab, there is no solution. You're just going to have to generate the stuff yourselves. So see how you get on, and I'll touch base with you on Thursday, I guess. All right, that's it. Bye for now.